Welcome to the Odyssey of Understanding. Today, we're diving into one of the most fascinating ideas in modern science, epigenetics. It's the science that says, you are not just a prisoner of your DNA. For decades, the common belief was that our genes were destiny, that our DNA acted like a rigid blueprint, predetermined, sealed, and unchangeable. If your family had heart disease, or diabetes, or depression, it seemed inevitable that you would inherit the same fate. But now, research shows us a far more hopeful truth. Epigenetics reveals that your environment, your lifestyle, your experiences, even your thoughts, can influence how your genes behave. Think of it this way. Your DNA is the sheet music, but your environment is the musician, deciding which notes to play, which ones to mute, and how loudly the melody should be performed. In this episode, we'll explore what epigenetics actually means, the science of how your environment can switch genes on or off, real-world applications in medicine, trauma, and mental health, practical ways you can use epigenetics to shape your own biology, and finally, the deeper philosophical question: are we the authors of our own biology, or are we still guided by forces we can't fully control? So settle in, because by the end of this journey, you'll never think about your DNA or yourself the same way again. Part 1 is DNA and the birth of epigenetics. To truly understand epigenetics, we need to start with the basics. Every single cell in your body, from your brain cells to your skin cells to the ones in your big toe, contains the same DNA. Roughly 20,000 to 25,000 genes are tucked inside that microscopic spiral. So here's the puzzle. If all your cells have the same genetic code, why doesn't your toe cell grow into a brain? Or why doesn't your skin cell start producing stomach acid? The answer is simple but profound. Not all genes are active all the time. A useful metaphor is to imagine a massive library filled with books. Your DNA is the library itself, containing every possible instruction. But in each cell, only certain books are open and being read, while the rest stay closed on the shelf. This is where epigenetics comes in. The word epigenetics literally means above genetics. It refers to the set of chemical tags and molecular switches that sit on top of your DNA, telling your cells which genes to read and which ones to keep silent. It's like sticky notes placed on the pages of your genetic library. Some notes say, read this often. Others say, skip this chapter. The DNA itself doesn't change, the book remains the same. But the instructions for how to read it change. And this idea, that gene expression is flexible and responsive, is revolutionary. It means your biology is not a rigid machine, but something closer to a piano. The keys are always there, but whether a melody or silence emerges depends on which keys are pressed, in what sequence, and with what rhythm. In other words, your DNA provides the possibilities. Epigenetics decides which possibilities come to life. This understanding didn't emerge overnight. For much of the 20th century, scientists focused almost exclusively on DNA sequence. The genetic code was seen as the ultimate key to life. But as experiments piled up, researchers noticed something strange. Identical DNA could lead to very different outcomes depending on context. One striking example comes from identical twins. They share the same DNA, yet as they age, their health outcomes often diverge. One twin may develop cancer while the other does not. One may experience depression or diabetes, while the other remains free of those conditions. If DNA were destiny, twins should be carbon copies of each other, medically and emotionally. But they aren't. The explanation lies not in their genes, but in how those genes are regulated, in their epigenetic patterns. So, what exactly is going on at the molecular level? That's where we turn next, into the science of the little switches that control the great machinery of life. In Part 1, we laid the foundation. DNA is the library, but epigenetics decides which books are opened and which remain closed. Now, let's step deeper into the molecular world, where the tiny switches of gene control are at work. And Part 2 is the science of gene switches. Your DNA is wrapped tightly around proteins called histones. Picture a long thread wound around little spools. This structure is incredibly compact. In fact, if you stretched out all the DNA from a single human cell, it would measure almost 2 meters, yet it fits inside a microscopic nucleus. The way this thread is wrapped determines whether a gene is accessible or hidden. Here's where epigenetics comes in. Chemical tags can attach to either the DNA itself or to the histone spools, changing how tightly or loosely the DNA is wound. And that simple change can decide whether a gene is turned on or off. Let's break this down into two of the most studied mechanisms. 1. DNA methylation. Think of methylation as the off switch. When a small chemical group called a methyl group attaches to a DNA strand, it acts like a piece of tape over a light switch, preventing the switch from being flipped. The gene is still there, but it's silenced. For example, in many cancers, tumor suppressor genes, the ones that protect you from uncontrolled cell growth, become heavily methylated. It's as if the body's natural safety system gets taped over and ignored, allowing cells to spiral out of control. But methylation isn't always bad. It's also crucial for development. Without it, cells wouldn't know how to specialize. You'd end up as a chaotic blob of identical cells, instead of a functioning human being. 2. Histone modification. Now imagine the spools themselves. If chemical tags are added to histones, they can loosen the thread of DNA, making certain genes easier to read. Other tags tighten the spool, hiding the information away. Histone modifications are like adjusting the volume knob on a stereo. Some genes are turned up louder, while others are dialed down. The beauty of this system is its flexibility. Unlike mutations in DNA, which are permanent, histone modifications can be reversed, allowing your body to adapt to new situations. Together, DNA methylation and histone modifications create an incredibly dynamic system of regulation. They are like the editors of a manuscript, highlighting, crossing out, and rearranging the story of your life at the molecular level. Epigenetics and the environment. Here's where it gets truly fascinating. These molecular switches don't operate in isolation. They respond to the world around you. What you eat, how much you move, whether you smoke or drink, how stressed you feel, the toxins you encounter, even the love and care you receive as a child. All of these can leave epigenetic marks on your DNA. Let's look at a few striking examples. Nutrition. In the 1940s, during World War II, the Netherlands experienced what's known as the Dutch hunger winter. Thousands of pregnant women endured severe famine. Decades later, scientists studied their children, and even their grandchildren. They found higher rates of obesity, diabetes, and heart disease compared to people whose mothers had access to normal nutrition. The famine didn't change anyone's DNA sequence. Instead, it altered the epigenetic marks, programming metabolism in a way that was passed down through generations. Stress and trauma. Another example comes from the study of trauma. Children raised in environments of chronic stress or neglect often show different patterns of gene expression compared to those raised in stable, nurturing homes. Certain genes related to stress hormones, like cortisol, can become epigenetically primed, making these individuals more reactive to stress throughout their lives. Remarkably, some studies suggest these changes may even be inherited. Trauma, in a sense, can echo through generations, not just psychologically, but biologically, lifestyle, and behavior. The hopeful side is that positive choices also leave epigenetic marks. Regular exercise, for instance, has been shown to change the expression of hundreds of genes related to metabolism, inflammation, and even brain health. Meditation and mindfulness practices appear to influence gene expression linked to stress and immunity. This paints a powerful picture. You are in constant dialogue with your genes. Every bite of food, every deep breath, every hour of sleep, and every stressful thought sends signals to your genetic switches. You are, in a very real sense, co-authoring the script of your biology. Epigenetics versus genetics, a subtle dance. At this point, you might wonder, does epigenetics mean that DNA doesn't matter at all? Not quite. Think of it this way. Your DNA sets the stage, but epigenetics directs the play. Genes provide the raw material, but your environment decides how that material is used. You can't change the script of your DNA, but you can influence which parts of the script are performed and which remain in the background. This is why two people with the same genetic predisposition for a disease might have very different outcomes. For one, the genes might stay silent. For the other, life circumstances may activate them. It's the dance between inheritance and environment, fate and choice. As we move into part 3, we'll dive into the real-world applications of epigenetics, how this science is revolutionizing medicine, mental health, and even our understanding of human potential. So far, we've explored how genes are switched on and off, and how your daily life shapes those molecular decisions. But perhaps the most exciting part of epigenetics is not just the science itself, but its applications. This field is transforming how we approach medicine, mental health, and even our understanding of what it means to heal. Medicine reimagined. For centuries, medicine has focused primarily on treating symptoms or attempting to fix what's broken at the genetic level. But epigenetics opens a new frontier. Instead of rewriting the DNA script, which is nearly impossible, we can edit the performance. Cancer research. Let's begin with one of the most pressing battles: cancer. Traditionally, cancer was thought of as a disease of mutations, broken genes causing uncontrolled cell growth. And while that's partly true, scientists now know that epigenetic errors play a massive role. In some cancers, crucial genes that suppress tumors are silenced through heavy DNA methylation. Imagine your body's emergency brakes being taped down. In others, genes that should stay quiet are activated, like the gas pedal stuck to the floor. This discovery has led to the development of epigenetic drugs, medications that can remove or add chemical tags, restoring balance. Some of these drugs are already in use for leukemias and lymphomas. They don't rewrite DNA, but instead retrain the cells to read it correctly. Regenerative medicine. Beyond cancer, epigenetics is reshaping how we think about aging and regeneration. One line of research looks at whether we can reset cells by reprogramming their epigenetic marks. Picture a worn-out old vinyl record, scratched, skipping, degraded, being polished back to its original shine. This is more than science fiction. Experiments in mice have shown that resetting epigenetic patterns can restore youthful function to old cells, even reversing signs of aging in tissues. Imagine a future where doctors treat age-related diseases not by replacing organs, but by rewinding their cellular clocks. Healing trauma through biology. But medicine isn't just about physical health. Epigenetics is shedding light on mental health and trauma in ways that are both sobering and deeply hopeful. We know from psychology that trauma leaves scars on the mind. But now, we also know it can leave marks on our biology. Studies of survivors of war, abuse, and severe stress reveal epigenetic changes in genes related to the stress response system. For instance, genes controlling cortisol, the hormone that floods your body during stress, may become overactivated or suppressed, leading to heightened anxiety, depression, or difficulty regulating emotions. And here's where it gets profound. Some of these changes can be detected in the children of trauma survivors. It suggests that suffering doesn't just end with one generation. It echoes biologically into the next. But there's hope. Because epigenetic marks are reversible, healing is possible. Practices like therapy, mindfulness, supportive relationships, and even certain medications can shift gene expression back toward balance. In this way, epigenetics offers a bridge between psychology and biology, proving that healing the mind can heal the body and vice versa. Lifestyle as medicine. Imagine a doctor's prescription pad in the future not only listing pills, but also writing 30 minutes of meditation daily, or more leafy greens and whole grains, and that being just as scientifically valid as a prescription drug. This isn't imagination, it's already happening. Research shows exercise activates genes tied to metabolism and brain growth. Nutrition influences pathways of inflammation and energy use. Sleep restores epigenetic balance, repairing damage from the day. Mindfulness downregulates genes associated with chronic stress. In essence, your daily habits are already a form of epigenetic medicine. You are dosing yourself every time you move, eat, rest, or think, shifting your body's molecular story in real time. The future of epigenetics. As we look ahead, the potential applications seem almost limitless. Consider personalized medicine, where your doctor could read your epigenetic profile and design a treatment plan tailored uniquely to you. Preventive care, predicting which genes might activate and intervening before illness strikes. Longevity science, unlocking ways to extend not just lifespan, but health span, the number of years you live in good health. Of course, these advances raise questions. If we can change our biological destiny, who decides what changes should be made? Could epigenetic therapy be misused, not just for health, but for enhancement? Would parents one day try to engineer not just their child's eye color, but resilience, intelligence, or temperament through epigenetic interventions. The science is dazzling, but it comes with responsibility. Epigenetics doesn't just empower us, it asks us to reflect on the ethical boundaries of shaping human life. Bridging science and humanity. At its heart, epigenetics reminds us that we are neither bound entirely by fate nor entirely free. We are a dance between the scripts we inherit and the choices we make. You are not simply your DNA. You are not doomed by family history, nor defined by every trauma you've faced. But you are also not entirely free from the influence of your biology. Epigenetics teaches us humility and hope. Humility because we see how deeply life shapes us. Hope because we realize that change is always possible. In our final part, Part 4, we'll step back from the science and explore the philosophical implications of epigenetics. What does it mean for free will, destiny, and our very definition of what it means to be human? We've traveled through the science of epigenetics, from switches on our DNA to how trauma, diet, and daily habits shape us at the cellular level. But now, let's step beyond biology. Because the real weight of epigenetics is not only in labs and clinics, it's in what it means for us as human beings. Destiny versus choice. For millennia, humans have debated the tension between fate and free will. Philosophers asked, are we puppets of destiny or authors of our lives? Epigenetics adds a new voice to this age-old conversation. Think of it this way. Your DNA is like the score of a symphony written long before you were born. But epigenetics is the conductor deciding which instruments play, how loud, and when to pause. You may not choose the score, but you can influence the performance. This perspective reshapes how we see ourselves. We are neither entirely bound by genetics nor entirely free. Instead, we are co-creators, sculptors working with the clay of biology, shaping it with the tools of environment, relationships, and intention. The inheritance of more than wealth. Epigenetics also redefines legacy. We inherit more than eye color or height. We may inherit echoes of joy and suffering, resilience and vulnerability. Generations carry forward not only wealth or culture, but also subtle biological imprints of lived experience. For some, this truth is heavy. It means that pain endured by parents or grandparents may leave shadows in their children. But it is also liberating. Because if epigenetic marks can be passed down, they can also be reshaped. Healing in one generation can ripple into the next. In this way, your acts of care, growth, and healing are not just personal. They may be a gift to future generations, written not only in family stories, but in biology itself. Responsibility and power. With knowledge comes responsibility. If your choices can change your biology, then each day carries a new kind of weight. Your morning run, your laughter with a friend, your quiet moment of gratitude. These are not small things. They are molecular acts of authorship, decisions that ripple into your cells. But responsibility doesn't mean guilt. Epigenetics isn't here to burden us with the idea that every bad night's sleep or stressful day ruins our health. Instead, it offers empowerment. It tells us, you can influence your body's story starting now. Spiritual echoes. Interestingly, many ancient traditions long taught that thoughts, diet, breath, and environment shape health and spirit. Epigenetics doesn't replace those wisdoms, but it gives them biological grounding. When meditation lowers stress-related gene expression, or when mindful eating influences inflammation pathways, we see modern science echoing timeless spiritual practices. Epigenetics bridges the material and the spiritual, suggesting that care of body and soul is not separate but intertwined at the deepest level. The future of being human. And yet, epigenetics also forces us to ask unsettling questions. If we can reprogram biology, do we risk playing God? Will future societies divide between those with access to epigenetic therapies and those without? Could attempts to enhance ourselves blur the line between natural and artificial humanity? We stand at a threshold. Epigenetics gives us unprecedented tools, but also demands wisdom, restraint, and humility. Perhaps the truest lesson is this: the ability to change does not mean we always should. Now the closing reflections. So where does this leave us? It leaves us with a vision of humanity as dynamic, resilient, and unfinished. Epigenetics whispers, you are not fixed. You are a story being written. and you hold the pen as much as your ancestors or your DNA. Every act of kindness, every choice to nourish your body, every step toward healing. These ripple into the deepest layers of you, shaping not only who you are today, but who you may become tomorrow. As we close this journey, remember, you are not just a prisoner of your past, nor merely a carrier of genetic fate. You are a living canvas of possibility. Epigenetics doesn't promise immortality or perfection, but it does offer hope that change is always possible, that healing is never wasted, and that the future is still being written in every breath you take. You've reached the end of today's journey on the Odyssey of Understanding. Until next time, keep exploring.